I was going to explain how transducers work. So let's get a box. Okay, great. We're going to copy that box a few times. Oh, come on. God, I hate these drawing programs sometimes. All right, we're going to we'll just do this. And then, so let's just say this is map. This is filter. And this can be, I don't know, map again. Doesn't really work that way, but whatever. It's fine. What are these little arrows? Like, go away. Part is when the mouse is stuck to the white area. Yeah, it's like, it's so bad. It's so bad. Okay. So we have map, right? And each of these blocks are values. So we map, we apply a function. We'll call it f of x over this, and we transform each individual value in this sequence. And then we're going to pass that sequence to our filter operation, which has a function p for predicate, and that returns true or false, right? And we map that over this thing. And then, I don't know, we'll have another function called g of x, and that maps this g, whatever it is. We don't really care what g is. You know what, let's use a concrete example. Inc, and then like, so increment, and then pause, so if the value is positive, and then, I don't know, addition. I feel like there should be one more here to go to reduce, because usually you do inc pause, and all the values that are positive. So this will give us all the values from here that are positive, and then pass them into this guy. Yes, that's right, Retro. Now I want a concrete example for map again. Maybe this should just be reduce. I'll just make this reduce. Reduce, and we'll say plus, reduce over plus, which is basically the sum of all the incremented positive elements for the original input collection, right? We'll call it Z. Anyways. Yeah, so each time, for these two reducing operations, map and filter, we are doing an operation on each thing, and we create an intermediate collection each time to pass to the next reducing operation. So what a transducer does is it takes these two things and creates a single reducing operation out of it, right? So if we say comp map inc and filter pause, this will create a single, you can think of it as like stacking these two operations. So we will get a single reducing operation that will do both, that will both essentially be like this. Yeah, right. It will filter out the positive values, and then it will it'll increment the positive values, and then filter out the positive ones. And so this way, you can kind of do this like for a whole bunch of different things. Like you can just kind of stack these, right? And so instead of having like 10 of these values, 10 of these functions where you just like do this, where you do this like a whole bunch of times, you really only do it once because you've parallelized them into like a composed function. If that makes any sense. Am I being clear? So, yeah. Instead of doing this whole thing, you would only do, well, just one. So one operation, one intermediate collection. And then if you wanted to actually like do something with it, let's see here. So if you wanted to do actual operation with it, got some code going here so I can stop yelling at this fucking shit. We'll say no, we should just make it a array. So what we could do is you could pass the transducer to a bunch of other things, but we'll just create a transducer doing exactly this, right? Map, inc, filter, pause. Now, if we want to use it, we go to, we can recreate our actual reduce at the end of the thing. Remember our reduce at the end here? We can recreate this with something called transduce. Transduce, and then we have our function. I think that's the signature. Yeah, and we have our function, so sum, add, and then we have our collection. Right? And then we could do this just like this. So it'll give us the same result. Right? But if we have a whole bunch of these intermediate reducing operations, and each one of them creates a new persistent collection, or realistically, it's more like a new lazy thing or whatever, we can parallelize those operations into one single operation, right? So transducers make most sense when you're working with giant collections, right? Mommy here. Let's make it pretty big. So the lazy version. I hope this finishes at some point. It probably will. It's just going to take him a hot minute. It might even crash because it's not a big int. Fuck. Anyways, in a while. Oh, there it goes. You do a transduce. It should be a bit faster. Yeah, there you go. See how much faster that was? Right? We'll just do a very simple time benchmark. Okay, so 3,000 seconds. Holy shit, meat boy. See how much longer that took? See how much longer that took? That took 20,000 milliseconds versus 3,500 milliseconds. But yeah, so this is kind of the benefit of transducers. But for small things, you're much benefit for small things. Like if we do like 100 or even 1,000, really. Yeah, like the time difference is not much for small values. So the big thing I asked you to run. Yeah, so basically transducers, that's what transducers do. Parallelize reducing operations, and they're very good for big things, big operations. Like large collections, essentially. The parallelization? No. It's not true parallelization like concurrency or anything. It's parallelization in the sense that like because you've stacked all the you essentially stack them on top of each other, right? Yeah, no, it's not. It won't create other threads or anything like that. Yeah, it's just kind of parallelizing the, sorry for the nomenclature, but like, yeah, it's parallelized in the sense that it just kind of stacks them all into one function. It's just basically just function composition, right? That's literally, and we literally use the comp function to do it, which is what you use to compose functions in Clojure. They don't make things worse, transducers. Why would they make things worse, Retro? Yes. So that is, yeah. Wow. We're like talking about all the like base performance stuff in Clojure. This is pretty fun. Transients, transducers. What else did we talk about? Chunking. Jeez. Because if they don't make things worse, it might make sense to use them anytime you got. I wouldn't say that. Like, there is a difference here. Like, this lazy version is actually faster than transducing in this situation, right? Well, I'm sure we could benchmark this to like with criterion to see if the lazy is really better for bigger collections. But you know it's way better for like smaller collections. Okay, this is a bad example. It took more time. See now this like yeah, the problem with Clojure is that like you kind of can't rely on this like time function. You have to do real benchmarking.